probability using cards. So card probability is very common in lessons. A standard deck of cards is an inexpensive manipulative that can be used for many concepts in math, including probability. Card games teach us problem-solving skills and strategies that help us develop these skills. Before you do some card probability problems, you need to understand what is included in a standard deck of cards. We all don't have the same experiences, and you might not have played card games growing up. If you did, that's great. This is a good refresher as well. So a standard deck of cards consists of 52 cards. It excludes the jokers. 26 of the cards are red and 26 of the cards are black. There are 4 what we called suits in a deck of cards. There are hearts, which are red, diamonds, which are red, clubs that are black, and spades that are black. Within each suit, there are 13 cards. They are numbered 2, 3, 4, 5, 6, 7, 8, 9, 10, and then Jack, Queen, King, and an ace. The ace is the one with an A on it. You can see that. Sometimes it's considered a low card in some games, and sometimes it's considered a high card, higher than a king in some games. Face cards are jacks, queens, and kings. So notice there's a jack, queen, and king in each suit. Face cards are the ones that actually have faces on them. So aces are not considered face cards. Let's look at some example problems. You're dealt 1 card from a standard 52 card deck. What's the probability of being dealt a queen, and then a heart, and then a queen or a heart, and then the actual queen of hearts? So let's start with the first one. What's the probability that you're dealt a queen? Well, we can go back and look at the queens in our deck. There are 1, 2, 3, 4 queens out of a total of 52 cards in the deck. So 4 over 52 would be our probability, but we can simplify that to 1 over 13. The second question, what's the probability that it's a heart? Well, you can look back at our deck of cards. This first row across are all hearts. You can count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 over 52, which simplifies to 1 out of 4. You might even see that simplified fraction right here. 1 out of 4, because one of the rows is hearts, out of the 4 rows. So the probability that's a heart is 1 out of 4. The probability that it's a queen or a heart, this one is where we get a little more complicated, because these are not what we would call mutually exclusive events. And you'll see what I'm talking about when we look at our deck of cards. So when we look back at our deck of cards, it said, what's the probability it's a queen or it's a heart? Well, here's my 4 queens. And then here are all my hearts. So there's 13 hearts and there's 4 queens. If I take those 13 hearts plus those 4 queens, I would get 13 plus 4, which is 17. And I would say 17 over 52. But there's a problem with that, because I've double counted this card right here, the Queen of Hearts. I counted it as a heart, and I counted it as a queen. That's what we mean by this is not a mutually exclusive event, because it can occur simultaneously. So we need to subtract off one of those queens that we counted twice. So you could write it out as 13 over 52 plus 4 over 52 minus 1 over 52, which would give you 16 over 52. And if you simplify that fraction, you would get 4 over 13. The last problem, what's the probability that you're dealt the Queen of Hearts? Well, again, look back at your deck of cards if you need to. There's only 1 Queen of Hearts in the deck. So the probability that you're dealt the Queen of Hearts is 1 out of 52. You can see those answers on this last slide. All right, I hope that helped you with cards. This is a single card being drawn. If multiple cards are being drawn, that's going to be considered a multi-stage event.